you want me to stop this until the actual...
Gentlemen, a long time ago at Easter cons there used to be lots of panels about extraterrestrial life and so forth, but we don't seem to be having them anymore. So I thought we should have one at Armadacon, and they wouldn't let me do it, so Gary's doing it. Ladies and gentlemen, Gary Eldridge.
I would stand up, but I can't be bothered.
Well, he is the chairman.
Exactly. Although I understand somebody, the convention changed their chair to a sofa.
Yeah, the Easter one, it was the comfy sofa.
Comfy sofa, which I think suits me better.
The sofa man.
Yeah, the sofa. Okay, so this is a two-parter. Unfortunately, you have to come back for tomorrow for the second part. It is a cliffhanger.
We promise not to cancel halfway through.
We'll do our best. So David asked for the Drake equation. I'm assuming he knew nothing about it, which is why I wanted to know something.
It's to do with ducks, isn't it?
It is, yes. It's, are we alone in the universe? It's basically what it is. So, for as long as humans have been able to, and aware of the sky, we've looked up and gone, I wonder if something's up there. They looked at the stars and is it little lights in a dark sheet, or my personal favourite, is it diamonds on glass spheres moving around us? I personally like that. I wish that was true. Unfortunately, we now know it's not. But we've also looked up and said, is there life anywhere else up there? We wouldn't ask about intelligent life because we know there's not up down here. So, over the years, people have written fiction. Oh, helps if I
Blue light on.
Yeah. Come on.
Hang on.
It worked just now.
Yeah, let's close out and read in.
Sorry about this technology. It's on.
I'm waiting for it to come back up.
Talk amongst yourselves.
Oh, mood music. Hang on, we've got a writer for that.
Yeah. Right, let's try this again. So, there we go. This man, Cyrano de Bergerac. Surprisingly, actually did exist. There really was a gentleman called Cyrano de Bergerac. 1657. All the stuff after it is loosely based on his life. And you can see he has an enormous nose. 1657, he wrote a book, a satirical novel, about a man who attempted to go, or went to the moon. Took him several attempts to prove that there was civilization on the moon. Okay. Then, Mr. Wells produced this book. Very good. I'm sure we've all seen various versions of it. Professor Cavor and Bedford went to the moon, found their insect-like aliens, hit them. If you see some versions, they hit them and they disappear in a flop. I think that might have been a Georges Méliès version. And then come back down. Yeah. Voyage dans la Lune. Brilliant. And Edgar Rice Burroughs wrote about this weird bloke who somehow managed to end up on Mars. So these are just bits of fiction. So there have been genuine scientists interested in this. So I'm sure we all recognise this chap, Nikola Tesla, one of the great geniuses who was too far ahead of his time. Does anybody recognise him? You might recognise his name, Guillermo Marconi, one of the pioneers of wireless radio. And if anybody but Martin recognises him, I'll be surprised. Do you recognise him? It's Lord Kelvin. It's Lord Kelvin, one of the great, Thomson, one of the great physicists. Oh, he's a practical physicist, my apologies.
As in the one that the name that the scale was named after?
Yes, and a lot of other things. They actually believed you could use radio to contact people on Mars. And in fact, Marconi picked up signals from Mars, or he claimed to, that disappeared when Mars dropped below the horizon. So even the greats don't get it right every time. But the real search for extraterrestrial intelligence, or SETI, as it's called, started really after World War II. One of the wars tend to produce an advancement in technology, for good or bad. Radio technology and radio astronomy came about from the war. So we had created these great radio antenna. After the war, they had nothing to do, so we pointed them up at stars. Oh my God, we were picking up radio signals. So somebody thought, maybe if we're beaming out signals, maybe aliens are beaming out signals to us. So in 1960, a gentleman, Frank Drake, did some experiments. He pointed a telescope at two stars, very similar to ours. 6 hours a day for several months. He tracked it, looked for nothing. Didn't deter him, so he decided to have a conference. So the main place to look was at about, for those people who know radios, 1.42 megahertz. For astronomers, 21 centimeters. Because it's an important signal. The most common element in the solar system is hydrogen. Funnily enough, at 21 centimeters, there is a specific band which is specific to hydrogen. So if you're looking at, you point a radio and set it to 21 centimeters, you can detect where the hydrogen is. So the thinking was, if ET wanted to broadcast to people who had no idea how to communicate with them, the most obvious wavelength was to look at 21 centimeters. Because people, astronomers, will be looking at that to detect the hydrogen. If you start to see regular beep, 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 beep signals at 21 centimeters, there's something there, something artificial. So that's what he was looking at. 1961, he decided to hold a conference with a group of eminent scientists. There was inventors, there was a neuroscientist, Carl Sagan, for those who remember him, was there, and a whole bunch, all different parts of science. They weren't just specifically astronomers or radio astronomers. He wanted a whole breadth of people. It's about 10 of them in total. In preparation, he realised he needed an agenda. So what he did was, he wrote down things that he thought would be useful. So when you're looking at it, there's certain things that would be useful. Remember, this is 1961 he did this. And you could probably come up with a number, N, to determine the detectable civilizations in our galaxy. So these are civilizations who we can pick up their signals. That sounds fun. And they sat down and they debated this and talked about this, and they developed this equation. Now I teach this I teach at GCSE astronomy at school, and one of my favourite lessons is doing extraterrestrial intelligence, because I put that up. It freaks them all out, especially if they're not a mathematician. Although I will say, I'm in a grammar school and I get the geeky ones. The ones who chose to do astronomy in a grammar school, you can't go much geekier than that. Still some will go, oh. But that's okay, because, we will be looking at, mine and Amanda's talk tomorrow, we will be looking in more detail at these things. So don't get caught up on what they are. Just know that it exists and know that it's really pretty. But it was never intended to be solved. This was not an equation. This must have hurt some mathematicians when they saw this. And, oh, we've got to solve it. No, it was never intended. It was just to do, just to show the main concepts that if you're going to look for extraterrestrial intelligence, these are the things you need to think about when looking for them. So you can see they're all fractions of. So you've got planets, maybe there's some there, but we'll go through that tomorrow. So it was never intended to actually be solved. It was intended just, it's a bit like Schrodinger's cat. It was never actually intended to put a cat in a box. It was, in fact, I think everybody uses it as a way of proving quantum theory, but actually I think he used it to disprove quantum theory, didn't he? Yeah, which everybody gets wrong. But it's just a thought experiment. That's all it is. However, there's things that we can do with it. So off and on, we've been looking for the last 70 odd years for radio signals. So why haven't we detected them? And what is the Fermi paradox? Okay, still with my first question. Okay, there are a number of factors, and we're going to talk about some of these as well. But I'm going to do a little bit slightly off the equation. So space is big. That's why. This is why I put this in, because everybody's got that quote in their mind now, and it's true. We've been sending radio signals out inadvertently. We've been doing it since the 70s, sending them out deliberately, but inadvertently, ever since Marconi started doing his first radio signals. So for nearly 200 years, we've been sending radio signals out into the universe. Some not very strong, some really powerful. So how far is that? How far in our galaxy is 200 years? So you see that little blue dot? That tiny little blue dot, which is also in the big one. That's how far our radio signals have gone. Okay? That's, if aliens, that's 200 light years, which in the galaxy is really, really tiny. The galaxy is 100,000 light years across. So the Galaxy song from Monty Python, there were quite a few things that were right, even if Brian Cox made them, Stephen Hawking made them change it. But the 100,000 light years across is accurate. So that's how far our radio signals would go. And our closest neighbour in that galaxy is 4.25 light years. This means, for those who don't know, it would take 4.25 light years for light to go from our sun to our closest neighbour, Proxima Centauri, which is how fast radio signals travel. So if I sent a message to Proxima Centauri, it would take 4.25 years to get there. Then they'd have to work out what I'm saying, then send a message back. Now, for those who are not that au fait with light years, that's 40.4 trillion kilometres. So Adams was right. Space is big, and that's our closest neighbour. That's part of the nebula that was formed when our star was formed. That's so Proxima Centauri. Some of you have heard of Alpha Centauri.
Yeah.
It's a double star system. Circling around it is a red dwarf called Proxima Centauri. It's part of the same system, but it has its own name. And at the moment, it's slightly closer than the double star system Alpha Centauri. So it's hard. You wait 10,000 years, and it won't be anymore, because it'll be around the other side. Then Alpha Centauri will be slightly further away. The other problem is radio signals propagate out. They go out. So if you put a radio in the middle of somewhere and the radio signal will go out in all directions, it goes out in a sphere if you're doing it from a point. From Earth it would go out sort of in a big cone, probably 180 degree cone. There is a little thing called the inverse square law. Yes. And this is the inverse square law. What this tells us is, you send a signal out, and at one distance away, for instance, this works for light, gravity, as well as everything else. You've got 9 things at 1r. At twice the distance, you've got the 9 over 4 times. 1 over r squared. 1 over 4, so it's a quarter the strength. You go out to 3 times the distance, it's 1/9. 16th. So you can see as you go further away, the signal gets less and less and less. The Voyager missions, we've all heard of those, and apparently they've just started communicating with them again, are not at the edge of our solar system. Theoretically, the edge of our solar system is about a light year away, but they're past an area we call the heliosphere, which is, it's the point where the solar energy, the solar wind, goes out and hits the interstellar media. It's still within our solar system. Technically, the gravitational effects of our sun is still within that. but they are just beyond that. We know that because the signal changed. As its Voyager's been going out, it's going picking up signal from our sun, and then it changed. So we know they went through the heliopause out into interstellar media. The amount of energy these Voyagers are sending back is barely enough to light a small torch for a fraction of a second. That's how little energy that they're able to pump out. Now, theoretically, more powerful aliens could pump out. But with our current radio technology, we can detect out about as far as 100 light years. So we can't even reach that little halfway, that little dot. So if we had an alien species that was compatible with our technology, they're beyond 100 light years. They would never detect us. That 200 light year, that energy would be so small. It's improved, and assuming they're sufficiently advanced, their detectors would get better. Our detectors get better all the time. But it's quite hard. And even then, the limit of them being able to detect us is 200 light years. If they're at 201 light years, they won't hear about us for another year. Okay, and then it would be really faint. Another problem is, and Martin's smiling at this, so I'm assuming I'm doing not too bad, or I'm just embarrassing myself. We're looking at 21 centimetre wavelength, that 1.42 megahertz, which is great. Assuming that that's the frequency the aliens are pointing and sending out signals. Most of our communication doesn't do it at 21 centimetres. Most of our communication is at all different frequencies. And if aliens are using radio waves to communicate, we may not be looking in the right area. In addition, that's the electromagnetic spectrum. You can see radio waves. This is brilliant. So when I say 21 centimetres, in fact I think it's that, isn't it? Just trying to remember. It's a full wavelength, yeah, so full wavelength, which means it's 21 centimetres long from one part to another. If they're communicating in microwaves, we're looking in the wrong frequency. If they're so alien, they're communicating in ultraviolet, game over, man. We can pick up ultraviolet rays. We use ultraviolet telescopes. It's really good. We look at the universe in so many different frequencies. But we're not specifically looking for regular signals. Occasionally you get various things. There's things called gamma ray bursts, which are sudden flashes in the gamma ray spectrum. Oh, what's that? We think we've got an idea of it. It's still a little flaky, but we're getting better at it. But we could be looking in completely the wrong region for it. Plus, if they do something like semaphore to communicate, there may be a highly advanced alien species that only communicates through sign language. What chances do we have of detecting them? And they will never detect us because they're not looking. We have all the ideas, and a lot of eminent scientists, a lot of people of different disciplines work together on this, and they do a really good job. But we're still humans. We're still looking at it from a human point of view. It may be they think in completely different ways. They may think sending out zeros and ones at 21 centimetres is not the way aliens would communicate with them. So we're not looking in the right place. And SETI is still going on, and we're still looking. We've looked at 21 centimetres. We're starting to look at other wavelengths now, but we're still looking in those frequencies that are in that region. So it may be there are billions, millions and millions of life forms out there, to quote Brian Cox. But we can't communicate with them because they don't talk to each other in the same way. We might be lucky, but still, you've seen that little pale blue dot, the distance. So, this is one of our problems. we may be thinking we're really, really clever and sending out a signal that everybody can detect. Hey, we put discs, we put naked pictures of ourselves on probes with discs with instructions on how to use the disc, how to make a phonograph, an LP player to play the sounds. We even told them where we are.
With the Earthlings, they've sent us a dick pic.
We even sent out where we are using a thing called pulsars, which are bright flashing things in the sky. They're basically dead stars. They're neutron stars that spin really quickly. And they spin at a certain frequency. And you can use those to navigate. If we ever go into interstellar space, we will likely use pulsars to navigate. But that only assumes they know what the hell pulsars are. And they know what to look for. It might take, yeah, you see the level, and that's only assuming that they think in a similar way to us. So, just to make David happy, because he specifically asked about it, let's talk about the Fermi paradox. So, Enrico Fermi, Italian-American physicist, really, really important man, did some amazing stuff. He was at a conference once, and they were having a little around the table. Probably there was a few drinks involved, because they're scientists and they like to get drunk a few times. And he just casually asked, "Where is everyone?" And that's it. He went off in his merry way, carried on doing the amazing stuff. But that hung around. People started going, "He's right. Where is everybody?" Now, assuming the X-Files is correct, all the conspiracy theorists are correct, they're here already. We just don't know who they are. So if the Drake equation has a, if we could calculate the Drake equation and have a really, really tiny number, the chances of there being life out there other than us is very, very small. If it's big, there's enormous amounts of life, and we will talk about that tomorrow. We will go into more details. We may even be able to put numbers in. So maybe they have a prime directive. After all, what's the Star Trek prime directive? Life forms that haven't developed warp technology. We've not left our solar system. We've got things going out there at high speed, unmanned, not left our solar system yet. We've only made it to the moon. 12 blokes have been to the moon, and a few robots who will probably take over running Mars. So maybe there's a prime directive. Maybe the aliens are out there going, too early. We're not going to talk to them yet. Have you seen them? Have you seen them? Have you looked at their political systems?
Oh, we found this problem of theirs. Let's upgrade it and send it back, Vija.
Yeah. Yes. Maybe they're not turning up because we named a country Belgium. There was a wonderful 2000 AD script called DR and Quinch.
Oh God, I remember that.
Where they went back in time and changed the continents of Earth to insult an alien race form and use those, what we would call land masses, as their language. It was hilarious. It was a long strip, and it all came down to just embarrassing their dean at university. But maybe, you never know. Another problem is space is big, blah, blah, blah. We have a thing called the speed of light, which is, at the moment, a limit. Nothing can travel faster than the speed of light at the moment. To be fair, we used to have a speed, people couldn't travel faster than 15 miles an hour, otherwise they'd die. So I don't trust physicists. But in order to get anything close to the speed of light, the amount of energy you need is unbelievable. So unless the aliens are advanced enough to find a way around this, they're developing their version of warp drive, wormholes, some alien spice that affects people and helps them travel, they're not going to get to us. If there were life forms on Alpha Centauri, or Proxima Centauri, it'd take them nearly 4.5 years to get to see us. And the faster you go, and we start getting into time dilation effects. So if we wanted to go to any reasonable planet that we could see, you're pretty much going, bye family, I will never ever see you again. Even if you were able to go into suspended animation. Because what we're interested in is finding out whether us on Earth, finding out whether they exist. You go, takes 500 years to get there. You go, oh look, there's aliens. 500 years back. Nobody cares because you've gone for there's 1,000 years. Look at our civilization in 1,000 years. How
Smoking
far
ruins.
things have
Welcome to
changed.
Mad Max.
Yeah, but after, you go back to 1024, how our civilization has changed. God knows what you'd find when you came back. Nobody's going to do it. I give you The Forever War by Joe Haldeman.
Yeah.
Exactly. That's exactly the problem. You'd need some people who never expect to come back and see their families. So, alien race, or us, our chances of actually getting to another planet in a lifetime are impossible. So that's a problem. And this is part of the reason, I think, the Fermi paradox, when Enrico said, where is everyone? It's because nobody can get here. Nobody, unless the aliens, unless these guys are actually here, and we just can't see them. I've seen several science fiction movies. Their chances of actually getting to talk to us. You know, we discovered a civilization 100 light years away. We say, hi! You wait 100 years. They go, oh, hi! 200 years later, your signal comes back. It's just, I think 2001: A Space Odyssey, when they interviewed Bowman and we're cutting out the delay because it was a 4-hour delay or something. You can't hold a conversation like that. So after 60 years, is the Drake equation still relevant? Yes. Various astronomers have made adjustments to it, as Richard said to me. There are many factors that have changed. There's a better understanding of those factors. So there are other versions of the Drake equation. But we're just going to stick with the original one because it's nice. But it still does what it needs to do because it's not a tool, it's not an equation to solve. It's a tool to help us understand. And even without the modifications, searching for extraterrestrial intelligence, searching for extraterrestrial intelligence is still a useful thing to do because, as well as it keeps a whole bunch of radio astronomers in work and research grants coming in, the technology we are using and the technology that advances bleeds into other parts. You know, one of the greatest physics experiments, the Large Hadron Collider in Switzerland. It's amazing. I've been lucky enough to go there several times. It's wow. It really is wow.
This is the one that hid under a mountain, wasn't it?
Well, no, it's under a plane actually, between two sets of mountains.
Oh, great.
It goes. Most of it's in France, but the headquarters is in Switzerland. But it's right by the airport. So if they did make a black hole, Geneva Airport would be the first thing to go. But and they spend a lot of money. Countries spend a lot of money. Our country spends a lot of money. It's estimated that something like about £2 for every adult in this country goes towards our research. But the technology that is created to look at the tiniest subatomic particles and smash them into small pieces like Lego bricks, it has advantages because it's a big multinational. There's no copyright. There's no proprietary rights. The super cooled magnets that they use there, the technology has been used in medical scanners. The World Wide Web came from the need to move large packets of data from one university to another without Tim thingy, thank you, and his buddies. Somebody would have invented it, but that's where it came from. But somebody would have probably have copyrighted it, and we would all be poor, and it wouldn't be as good. The fact that the internet existed due to the US military and university is irrelevant. What they did is they created the HTTP that created our web. And actually, if you go to Geneva and you go into the office, there is a corridor that has a little sign saying, "Welcome to, this is where the World Wide Web was created." And they actually have the original server. It's a little black box about yay big. It's about the size of Dave's printer with a little label, white label on, so you do not turn off. That was the first web server. But what I'm saying is that although this it might seem a bit blue sky is good, because blue sky creates amazing stuff. You might not understand it, what you're going to use it for, but some bugger out there, some capitalist will go, "Oh, we could use that to make a lot of money," and change our lives. So tomorrow, Dr. Bob and I will come back and we will look at a bit more specifics about that. We're going to tag team, because I'll do the astronomy, do the biology, and we'll see if we can solve the Drake equation. Yeah, I'm going to go my PhD in material physics this way, or my Nobel Prize. So, any questions? I don't know how much of that, if there was anybody who did get any of the specifics on that.
I was going to ask David a slightly personal question, but are you a physicist yourself? Or
Absolutely not, I'm a chemist.
Oh, right.
My training is chemistry, so I apologise to the physicists in the classroom. However, I do have an interest in space, and I teach GCSE astronomy, and part of the course is looking at SETI. So some of this, like that slide, I stole right from my PowerPoint. And Dr. Bob said, "Oh, that's pretty, we'll use that one." So I have an interest in it. Any other questions?
You were saying about this particular frequency
Yeah.
that you think is a good, or people think is a good one to look at. Do you have any idea when humanity started sending out significant emissions at that frequency, and how that changes the size of your blue dot?
Yes, I think it was, if I remember right, it was in the 70s, some of the earliest. Arecibo was one of the first places they actively said, right, let's send a signal.
So the blue dot is...
So the blue dot is actually quite small, but the blue dot covers the general radio signals that are coming out. So, but yeah, actually saying, "Hi, we're here," you're talking 40, 50 years at the most. So yeah, that tiny blue dot has a smaller little red dot in the centre of it. You probably couldn't have seen it.
No.
And you're going to talk about this tomorrow, I guess, but there is also the idea, do we want to send out messages?
Actually, we hadn't, but that's a good thing to raise. That again, I talk about that in when I'm teaching, because I get them to look at the different things, the good things and the bad things. Do we want to?
No.
It will change the world. It will change religion.
Why does V, the TV series, spring to mind?
Well, a lot of science fiction involves aliens come and kill us.
No, we come as friends, but your lunch.
Yeah, but because actually aliens turning up and being nice to us doesn't make very good films or TV series. However, one of the best ones I can think of film-wise is Arrival. If you've seen that one. And that is an example of one of the problems. If we ever communicate with aliens, how the bloody hell are we going to be communicating? It's hard enough to communicate between two races, or two countries. You know, some of us are lucky enough to speak multiple languages, but I've been with a German for over 30 years, and I still have problems with German. However, we can learn because we've got commonalities. I can go, nose, Nase. Oh, okay, that's German for nose. That's brilliant. If you have nothing that resembles a nose, you end up with Darmok. And that was, again, that was probably one of my favourite TNG episodes, because it showed you how hard it is to communicate. They even spoke the same language due to communicators, but they didn't have the same concepts. If you don't have the same concepts, if your cultural background is so different, you're never going to be able to communicate, or it's going to take a long, long time. And the only reason she managed to learn to communicate was because they were affecting her mind and she was doing time stuff. Sorry, spoilers. It's a great movie though. Vicky.
SETI.
Yes.
I'm sure a lot of us in the 70s, 80s were encouraged to leave their computers on and get into SETI and help everybody look for it?
Yeah.
Was that a load of rubbish? And is it still happening?
No, it's not happening. The SETI Institute shut that one down. It didn't produce any useful signals. However, what it did do is it was the first of the citizen science stuff. So yes, for its job of, can we detect any alien life signals? It was a complete waste of time. However, I think it promoted the whole citizen science, which has become an unbelievably useful tool. A lot of astronomers, and it was started off with astronomer. Did any of you watch Sky at Night?
Yes.
Chris Lintop was one of the early people with the Galaxy Zoo. He was one of the first people to get that up and running, and he was involved in that. That was an early citizen science thing, and they used that to identify galaxies. And now it's expanded, then it expanded to identifying creatures in the bottom of the ocean. But what it did, it was the first one of those that people like Lintop went, that's a bloody brilliant idea. Astronomers often don't have time, professional astronomers don't often have time to go and look for things like comets. They're too busy looking at that obscure little star up there and doing analysis of it. It's the amateurs that often make what people will consider the interesting discoveries, the comets and the, oh, that's weird. And then they tell scientists. So, yes, citizen science is really, really important. And I think that was the first of it, because it did encourage us. I did the same thing. Several years I had packages of, you realise now that actually it was quite a drain on the electricity, but we didn't realise, we didn't think about it at the time. But so in that respect, yes, it's important. For its actual purpose, a waste of time.
Why do you say it was a waste of time? Because not finding something doesn't mean it's a waste of time.
This is a scientist talking. Because
and also, I mean, I just mean, if it did it significantly help people to analyse data? Or
yes,
not?
yes. One of the problems is they didn't have enough computer space, computer processing power to analyse all the data that was coming down. You know, you'd spend a night, and the amount of data you acquired took probably a couple of years to analyse. So yes, you're right. So the core thing of, did we find any alien life form? No. But you're quite right, as a scientist, we eliminated something. We realised that that's not what we should be looking at. That's not the way we should be looking at. We need to change our models and our approach. So, and yes, so the core part of it, no, but it had a lot of very useful stuff, and it made people probably more important, made people interested in science and SETI.
Because you made the clear case that space is really, really big.
I think I've emphasised that several times.
But of course, there's the other dimension. Space has been going on for a really long time as well.
Yes.
Because I've heard one possible solution to the Fermi paradox is there might well have been great civilizations. There might well be lots of civilizations in the future. But having one right now, or within listening distance of us and communicating distance, at the right stage of civilization.
Yeah. And that comes into the Drake equation. It actually comes into the Drake equation. We'll talk about that more tomorrow. But yes, that could be one of the reasons. There's just nobody there at this point in time. We're very lucky. We managed to get communications. Other races could have died. But we'll talk about that part of it in tomorrow's talk. Oh, David?
You obviously said about the size and the distance that we've so far been able to communicate, or try and communicate to. So that suggests that any alien civilizations that might actually be able to listen, the only way that we'll ever contact them is if they contact us that are more advanced and can maybe see further, quicker, whatever.
Yeah.
And if they could do that, would they want to talk to us?
Maybe not. The problem is there's so many different variable parameters that could, just one thing could go wrong, and one thing could be out of alignment for it just never to be able to communicate with them. Just not using the right wavelength. Just not caring. Them going, have you seen those? Have you seen their television? Poof.
See what they do to each other.
I saw a documentary on this, and it said that standard
There's
colony ships,
two for it.
standard whatever that means,
Yeah.
so at pretty slow speed from one star system to another, and then replicating and going to other ones, could easily have colonised the entire galaxy by now.
Yes.
in time it's had.
Yes. But we would have picked something up,
Yeah.
which makes you think maybe that didn't happen, maybe it didn't last long enough. Again, we don't know. Most of this is going, but
Question.
we'll go tomorrow.
Question.
Yes.
A lot of people assume, I use that word dangerously, that there's life in this galaxy. We may be the only life in this galaxy, and the rest of the aliens are in other galaxies going,
Yep.
I'm sure there's someone out there.
We have several galaxies surrounding us. They're satellite galaxies. Our closest major neighbour is about 2 billion light years away. Although it's getting closer. In about 2 billion light years, it's going to become part of us. Surprisingly, we're not going to suddenly crash into each other. Just in case you're worried, if anybody is planning on living forever and ascending into a higher life form, an energy life form, so they're around in 2 billion, 3 billion years' time. There's so much space between them. It's just I've seen the simulation. It's a beautiful ballet of stars doing this, settling down. So yeah.
I'll call you back when I'm a Vorlon.
Yes.
So if I get this right, you're saying the chances of anything coming from us are 1,000,000 to 1, you said.
Yes! Yes! However, the chances of sending anything is really, really high because we've done it and we're getting good at it.
Visions of a little scrapyard, Mars scrapyard. Please dump your junk here.
Any other questions?
Does the equation, does the equation allow for anything in the future we might find, say, like we're looking for life on Mars at the moment that might have been? Because if you find it in another place, then the chances of it being...
It does change some of the numbers. What you're going to remember is that equation. Put it back up because it is very pretty, and I've got a really nice image of it. That equation was created in 1961. They did do some estimates, and things have changed. And again, without preempting tomorrow's presentation, things have changed. And we'll look into some of that. So, yes. But we'll tell you tomorrow. Come back.
But I guess what you're saying is, if you just if you find bacteria, say, on Mars, the equation has changed because the last 3 factors to the right are all gone.
There is one of those factors that will change considerably. Yeah. But again, I don't want to preempt Amanda's talk too much, because that's the biology side of it. Yeah, it would change things. And that's part of the reason that the space agencies are spending a lot of time looking at various places. There are three major candidates for the possibility of finding actual life, if we ignore Mars, because we think we may detect evidence of life, but it's probably fossilised and extinct. There's Europa, which everybody knows about. There is Titan. Titan has a liquid on its surface. It's methane, but it could be, maybe. And then there's another one around Saturn called Enceladus, which we know has a liquid underneath its ice because it's shooting jets of water out into space. It has large organic molecules, and there's evidence there may be what we call the smokers, the stacks, where we know on Earth the thermal vents on Earth produce life that has no connection with the sun.
I said a lot of this has been covered in the new Brian
Yes.
series solar system.
Yeah, a lot of it is covered. So that's a really good series, by the way.
Yeah,
if you've
the
not
solar
seen
system,
it,
yeah,
very
yeah,
good.
been watching
Very
that.
If you can put up with Brian Cox, He's
Yeah,
not too bad.
I can
He's not my
explain.
favourite physicist. He's my third favourite physicist after Martin and Jim Al-Khalili.
I know they've
Go on.
I know they've looked at Mars, maybe the other ones.
Yeah.
Some people have even looked at Venus in the early days. I know for a fact that certain other scientists have also gone, yeah, there might have been a planet here before us, which is called the asteroid belt now, the planet that never was.
Yeah, it was never an actual planet. There was, when I was a kid, it was an idea, oh, maybe there's a planet that's destroyed. There's not enough mass in the asteroid belt.
Right.
We believe there could have been up to 50 planetary bodies in our solar system. Some of them are smashed into other things, some of them have disappeared off into the universe. But yeah, the asteroid belt, there was believed, somebody named it, but nowadays we realise there's not enough mass for them to actually have ever formed a planet. So I saw Martin nod, so I'm all right on that one.
Can I just defend Brian Cox? He's not my favourite physicist either, but his TV programmes have significantly increased the number of people studying physics in this country, and we all owe him a debt.
Yes. Actually, Brian Cox and the Big Bang Theory.
Yes.
Weirdly enough, when the Big Bang Theory got popular, I work in a grammar school in the science department, and I used to work in physics. Our numbers tripled. We went from 2 classes to 4 classes at A level. And pretty much within a couple of years of the Big Bang Theory going off air, our numbers dropped. Our physics numbers dropped because suddenly there was no cool, weird physicists to watch on TV. And it's a weird thing to do that. But yeah, Coxey and the other TV scientists like Carl Sagan did the same thing. They all promoted science. And what I joke about disparaging him. He can be sometimes annoying, but he's a really, really good physicist in his own right. He's a really good communicator of science, generally, I think.
And he's quite cute.
I understand it.
He's about my age as well, so so I wonder where I went wrong.
He does it.
Yeah.
He does it to a level that us non-scientists can understand.
Yes, and that's a really hard thing for scientists to do. To not dumb it down, but to teach it at a level that people who don't have the advanced knowledge have. It's a really hard thing. I've met a few people, really, really smart, they just can't bring it down. And it's not about dumbing it down, it's about teaching at the level and that level of information that the people have. You know, you could teach the stuff to first-year physicists that you could teach to third-year physicists, could you?
I mean, Paul Dirac, Nobel Prize winner, great physicist, wrote a book about quantum theory, and he thought this is the way to explain it. If you asked him, if you said, I don't understand that, can you explain it again? He would repeat verbatim what he had said.
Great physicist, really not very good at teaching, which is why Feynman was so great, because Feynman had that ability to bring it to a level that anybody could understand, and then move it up as he needed to.
Is this why The Brief History of Time is the most unfinished book?
The History of Time is fantastic.
It's a great book, but
you read it and you can understand everything in it. Then you turn the page and you understand that. But as a layman, you've completely forgotten what was on the previous page.
Yeah. There's a great book called Teaching My Dog Quantum Mechanics. I just saw Martin's look, and Martin taught me quantum mechanics. It was my best topic, and I still don't understand a word he said. Because you started off by saying nobody understands this, which gave us a great chance to succeed at that course. But I read it, and that was fine. I got much of it until I reached a point of my mathematics where I went, nope, gone, done. Put the book away, never read it again.
I must admit, you were talking about people getting interested in astronomy and all that lot. In my case, it was a certain monocled xylophone playing guy
Patrick,
who got me into what is
Patrick
up there first.
Yeah, he was the most successful amateur astronomer because he wasn't trained, he learned himself, and was just, that show is unbelievable, and still the fact it's still going after all this time.
Yeah, even when it's like his legacy.
Yeah.
That is his legacy, is the sky at night.
Yeah, Louise.
I think the real claim for me with Brian Cox, I did find him a bit difficult to listen to and understand because just bigger.
Yes, yeah, he can be
But-
quite wary some days.
But it's also useful to have the image, you know, the entropy. I think one of his programs went to Namibia to observe the desert town had been taken over by sand, and then it kind of like actually got the concept of entropy across.
Yeah, yeah, he's very good at explaining. I'm never sure how much of it is his ideas and how much of it is his team of research assistants who go unnamed, because that's usually how science works. But yeah, he's very good at it. For me, it was Carl Sagan. Carl was the one who first was one of the him and Heinz Wolff.
Oh, Heinz,
Were
the
the
great
two
egg rice.
scientists that taught me and made me go, science is fun. Johnny Ball did it a little bit with maths, and I'm trying to think. Yeah, and there was another guy. I can't remember. They did Rough Science. There was a show called Rough Science where they plonked a bunch of engineers and scientists on a desert island and told them there was a chemist there, and I remember watching him as a kid in television, and I went, that's cool, and that's one of my influences in chemistry. So let's go completely up. But actually, the Drake equation. If we get back to the Drake equation is a really good way of introducing SETI to people and making them go, oh, that's interesting. I don't understand any of that, but I'm interested in learning, and that's the important thing.
You may have said it, in which case apologies, but who funds SETI nowadays?
SETI, as far as I'm aware, is a non-profit charity. So I think they get probably funding from various research grants and very rich people. It's definitely not a government run organisation. If I remember right, it's a non-profit charitable organisation. And there's probably a lot of people who put in a lot of time that don't get paid for it, and donating telescope time.
How is SETI progressing their search now if they're not going up?
From what I understand is they're starting to widen that frequency range. To be fair, I say 21 centimetres, but actually they were looking either side of it. I think they're starting to widen and consider the possibility that there may be other frequencies to look. SETI I know some about, but I'm not an expert on it. So I've read various websites, but yeah, as far as I'm aware, they're starting to look at other frequencies and think at other ways of doing it. But it's still going strong. It is still going strong.
I'm rather glad to hear the change in frequencies, because one of the things, as somebody's been in telecoms for years, you go to a channel or to a frequency, someone's already there, you go, I'm not to be heard here, I'll go to the next channel.
Yeah.
So for me, the thing would be, right, we've got a lot of noise in the hydrogen band,
yeah,
double it, go somewhere else.
Yeah.
And pick something that's...
Well, that's it.
Yeah,
so
20 makes sense.
21 centimetres is an easy one because it's a very distinct frequency. Anybody who looks at the radio wavelength or looks for hydrogen is going to notice. It's a very distinct thing. You're right, there's a lot of noise there. But in reality, they're looking for tiny amounts, tiny differences. You've got that background noise and you can remove that. If you know you're looking what to remove, you know, like any of this baseline text, you remove it. So you're looking for tiny amounts. But what it is, it's not so, there's a blip, there's a blip. It's looking at blip, 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 because that's what we would expect to see. We would expect to see, and there's been a few. There's the wow signal, which never got repeated. For those who know, there was a bunch of radio astronomers just looking at various things in the universe on the radio wavelength, and they suddenly got this regular repeating signal. Meep, 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 meep. Never got it again. Disappeared, or they went away looking for other, because it's all automatic. You put it on at night and go to bed, and in the morning you look at your data. They went back to look at it, gone. Nobody knows what it was. Could have been an alien spaceship flying past in front of the telescope. You don't know. But
Could have been a microwave oven in the research.
Yeah. Oh, yeah. The joy. I've read stuff. The joys of radio astronomers getting rid of background noise. There was. It's completely off topic, but it gives you an idea of it. The first guys who detected microwave background radiation. Two blokes who were doing some research on something completely different. Bell Laboratories. They got this big horn-shaped telescope. Oh, we got this noise. Oh, bugger. So they went to the extent of trying to remove it. They even went to the extent of going in with a pair of brooms and cleaning the pigeon shit out of the telescope. Because it was like a horn. No, and it turned out what they were detecting, they didn't realise until they met up with some other scientists who were looking for it, that they'd found the cosmic microwave background radiation, which is the energy signature from the Big Bang. It's one of the major pieces of evidence that there was a Big Bang instead of there being a steady state. Because there's this energy that across the whole sky, no matter where you look. That was their problem. They thought if it had been directional, are we going to eliminate it? It's across everywhere. They thought, right, pigeon shit. That's not what it was, but they came to that. They got so worried about it. How long have I got? Yeah.
2 minutes.
So, is there going to be a bing noise at some point?
We hope. We can only hope. If we do, can you imagine how that would change the universe? If we could contact life, even finding life on Titan or Europa, that's not the same as ours. Can you imagine how that will change the universe? Our view of the universe. And if we met aliens, if we met that guy, religion is going to go into a freak out. Because most monotheistic religions believe God created you in your image.
We've all seen Paul.
Yes. So they'll find a way around it.
I'm more worried about getting to Europa and finding a black monolith.
Yeah. That's also
2 by 4 by 9. Oh, we'll leave this one here.
Mostly to be continued tomorrow. Amanda and I will look into a bit more of the details. We have another PowerPoint.
I saw some extra details that should be on the PowerPoint but aren't going to be.
Okay, so yeah, we'll waffle again for another hour or so and hopefully solve the Drake equation and we'll get our Nobel Prize in physics. Which will be some party. Thank you very much, folks.
Thank you.